after that, you have a slope building, or you have
Go bring my wheelchair. Where'd you get a wheelchair?
Villa, dude.
50 bucks?
Nah, this one is Bill was it? No.
63 bucks. Everybody,
That ain't no bargain shop.
We're
not pregnant.
Alright. Hey, hold on, I'll fold it up. Don't worry.
Alright.
looking snazzy, Pittsburgh.
You like my thrifty,
I'm American.
Amazing. Good on you.
Don't worry, we're good.
it's funny. I feel like a car salesman.
You like to like
I got it like 2 years ago. I wore it from like 2 years ago. It's good. Because what I did is I wore a type shirt.
pomegranate, strawberry.
Okay, we're just doing a couple minutes. Okay, hey. A couple minutes. That's it. Very easy. Alright, hey. Here's what we're going to go through today. We have a couple notes that I want to cover. Then we'll be done. You'll be done plenty early. I know that we don't have class tomorrow. That's fine. I just want to get the notes so that everyone in this room gets the same notes as every other class that will meet tomorrow. Does that make sense? I don't want to put you guys ahead or behind anyone. I want you right on the same par so that way on Monday we can pick up and we can go from there. Okay? Questions?
Could you possibly keep an eye on the time for like 12:55?
Yeah. I have to leave at the same time you do because I got to go down there for the homecoming. So we'll have Mr. Heemstra will come in here.
Are we doing the King tomorrow?
Okay, we just go.
You're not allowed.
Today? I thought it was
Say we're in June, Father. If our grand marshals don't show up, like they're busy, we'll have to you. Thank you. Family lab. Should be excited about that.
Yeah, right.
That's what the bases are.
I'll do it.
Just like
I need this. I'm going to do this every day.
Hey, listen, see? Okay, I got a couple things I want to cover here. Okay. All right. So, first and foremost here, let's go through just a few notes. Okay. Okay. All right. Hey, what we hinted at yesterday. We talked about, we talked about all the different shapes of the polyhedrons, or polyhedra if you want to go plural. We talked about the regular ones. The last thing we were going to discuss, and I showed this slide briefly. This is the picture that I pulled right from the book. This is the formulas that they give you for surface area, volume. They have both formulas. Now, here's the thing. Don't sit there and try to memorize these formulas. Okay? There are certain ones up here, yes, you have to have them memorized. Certain ones. Okay, and I'll tell you which ones those are. But it's not all of them. That's ridiculous. There's a ton. A lot of these are pointless. Unless you get to a certain, type. Okay, so, for instance, when I'm finding what this S stands for surface area. Surface area is one of the easiest concepts if you just think about what it's asking for. So that's what I want to talk about, okay? We're going to talk about volume today and surface area. And what we're going to do today is just do one example of a cube, a rectangle, or a prism, and we're going to do one example of a cylinder today. That's all I want to cover. We're going to do one example where we find both numbers. Now, I will explain how this works. Hey, stop talking about this. It's already annoying. All right. So let's go through an example of what the surface area is. Now, what most people don't realize, they forget the definition of area. So if I look at just a plain, just a flat surface, like a rectangle of some sort. what area is, it's the number of tiles that fit in that object. So like if you look at the floor in here, there's square tiles. We could actually find the area of this room by just counting the tiles one at a time. Well, that's silly. We have an actual formula for it. What do most people remember about the area of a rectangle?
Base times height.
Base times height, or
Width
length times width. It's however you want to think of it. When I was taught it was always length and width, you guys always think it's base and height. That's fine. It's the same number. You multiply those two numbers together, it gives you how many square tiles are on the floor. So if I actually had that number, which this is like 30, and I go to the back, that's like 45, you can multiply those numbers and tell me how many little square tiles are on the floor, give or take a few. All right? So that's the idea. Well, when they talk about a three-dimensional object and they want surface area, what you're basically doing is you're finding the area of each of these faces, one at a time, and then you have the bottom, then you have the front and the back, the one in the back there. So there's literally 6 faces there. Top, bottom, right, left, front, back. That type of thing. So you have to find the area of each one separately. And once you find the area by just taking like base times height or length and width, whatever you want to use, then you have the areas and you just add them together. That's why I don't memorize this stupid formula. I don't even have that even in my arsenal in my head. I don't even think of it. I just find the areas of each one, add it together. Because that's common sense. So what I want to do right now is do one example how you find the area here. Then we'll come back and we'll talk about volume for that object. Okay, so let's start with that. I'll get rid of this picture here in a second, but I'm going to copy and outline it. So we can use this here. I'm going to do the three-dimensional part. All right, let me hit the lights for me, please. All right, so if we're dealing with a cube here, right? And I want to find the surface area of it. I just need a couple numbers. So I need one number, please. 7. Okay. You want inches, feet, centimeters, what do you want? Miles. Okay, 7 miles. Okay, so 7 miles. I need one other number. 4. 8. Or 8 and 4. Okay, so 8 miles and 4 miles. All right, so those are my numbers for this. So if I want to find the surface area, so each box separately, okay, front, back, top, bottom. Basically, all I need to do is find the area of each individual piece. So I'll find the area of, let's do this piece over here. That's the side. So that side, if I look at it straight on, has a dimension of 4 miles. And the bottom, the base of it, is what, 8 miles? That's the side rectangle. That's over there. 8 by 4. So what happens when you multiply those? 32, and then it's square miles. So this is how they write square miles. Miles squared, or square miles. That's the same label. Okay, because it's how many squares fit in that object. Okay, that's how they do like for farming. They do acres, but it's by square mileage. Right, that's the idea. Okay, so that's that number. This number that we just found, 32 square miles. That is the same as the one over here on the other side. It's supposed to be a perfect rectangle. So this side, it would also be the same. So this would also be 32 square miles on this side. Now, front. What's the dimension of the front of the box?
56.
Okay. Nope. Front of the box.
7.
What's this number?
4.
This is 4,
Oh, yeah.
and then the bottom is 7. So if I draw that, yep, it's 28, right? 4 miles by 7 miles. So we multiply those together, which everyone's saying is 28, and it's square miles. And that would be the same, or if you write square miles like this, that's the same as the one in the back. So that's the one that's back there that you can't see, like in the back. Okay, so there's 28 in the back, 28 in the front. Now, let's figure out the top of the box. The dimensions for the top, it's 7 and 8. You're absolutely right. There's 7 miles because this number can literally be transferred up. This 8 number can be transferred up. So that top of the box is 7 by 8.
Which is 56.
Yep. So that's 7 miles by 8 miles. And if we multiply that, you're absolutely right, that's 56 square miles. Square miles. All right. And the final answer here to figure out the total surface area is you basically are adding these parts here. You're adding them all together. So it's right, the left, front, back, top, bottom of that box because there's 6 facets, 6 sides. So basically you're just adding these twice. So this is the right side and the left side. So it's 32 square miles plus 32 square miles plus the 28 square miles, plus another 28 for the front and back, 8 miles squared. Then the 56 square miles, plus another 56, because that would be the top and bottom of the box. And when you add them all up and you get your number, that's the total surface area. Does that make sense now, like how I'm doing that? Top, bottom, right, left. I don't memorize those stupid formulas from the book. Like, those are pointless. If you just know what area stands for, you don't need to memorize a bunch of stuff. You just need to know how to find area of a rectangle and just add them. Okay? The hardest part probably about this picture is just knowing where the dimensions are. Knowing like this front of the box is 4 by 7. Because this 4 literally transfers to here. Or this 8 transfers up, and the top of the box is 7 by 8. That type of idea. Okay? All right. And again, if you were to add those, your answer would be so many square miles. Right? I don't know what that number is. It's pretty big. All right. Questions, comments, concerns? Okay, now, let's talk about the volume of that box. Volume is a little bit different. Volume isn't the tiles on the floor. That's area. What volume is like the image I always have in my head is if I was in this classroom and I'm trying to stack these desks. Like, put all the desks on top of each other, fill it to the back of the room. How many desks could I put in this room? It'd be quite a bit. What a farmer would think about is like how many bales, like square bales they could throw in a barn. Or how many bushels could fit in a silo. That would be volume. It's space in a three-dimensional object, not just floor plane. Okay? So the idea here is when you find volume, it's the easiest thing in the world, especially for like a rectangular prism. Right? The rectangular prism, when you find the dimensions, it's just length times width times depth, or length times width times height, however you want to think of that. Because you're finding basically the area, and you're taking it times how far back it goes. So the best, like the image that I always have in my head is imagine you had a deck of cards in your hand. Like, how many cards are on a deck? 52? So you have a deck of cards. You're going to find the area of the top card. Just the area, length and width, right? And what you do is once you have that area, you take it times how many cards are stacked on top of each other, so 52. And that would be the volume of that stack. But instead of, 52, you actually figure out what that measurement is in like millimeters. So that's the idea. So that's why we do length, width, and depth. So in my problem over there, I'm using the 7 miles times the 8 miles times the 4 miles. Those are the dimensions, length, width, and depth. And when you multiply them together, it's 56 times 4. 56 times 4 is 4, carry a 2. 5 is 224 cubic miles. Yeah, it's 224. All right. All right. Any questions with what volume is? It's like the space in an object. It's easy for a rectangle, like a cube kind of thing. You just multiply the 3 dimensions you have. Okay? But area takes actually some time. Now, let's go back to that picture, and let's not look at the rectangle here. Let's look at the cylinder, like the pop can or the Campbell soup can kind of looking figure. So, pull this back up. Okay, there we go. All right. We're going to look at the soup can now on this problem, or on this picture. So I'm skipping over the pyramid. We'll come back to that here in a second and talk about why that formula is really weird. All right, so now for a cylinder, it's kind of the same idea, right? For surface area, you got to find the area of the top, area of the bottom of the can. So, but these happen to be circles, so we'll have to talk about the circle formula to find area. And then you have to find the area of the weird curved part in the middle. And this is the part that most people cannot wrap their head around. Like, how do you find area of this band right here? And what you do is you basically break it into pieces. So here's how I find surface area. So imagine we had a soup can, and we're going to add up those areas. So here's how it works. Okay, so here's my soup can over here. Okay, so the first thing you need to do, you need to find area of the top. To find area of the top, it's basically the radius of that circle squared times pi. So it's pi r squared. So whatever the radius is, you square it, you take it times pi, and pi is the label. That's the area. You'll add that to the bottom, because this area on the bottom will be the same. That's the bottom of the can. So you'll add that to itself, whatever it is. And then for the weird band in the middle, this is the part that some people can't see. They can't figure out how to find the area of it. Basically, imagine you took the can and you took the top and bottom lid off. Okay, so now there's no top and bottom lid. You peeled them off. And you cut straight up the can itself, and you're going to lay the can flat. So you're going to unravel it. So the top and bottom of the can are sitting over here. But the can itself, you're going to take all the metal, the tin, or the aluminum, and you're going to unwrap it, and this is what it would look like. You unwrap it and you lay it flat. Well, what is that shape? It's a rectangle. The rectangle has a height to it. That's how tall the actual can is. Well, that's this number. How tall the can was. That hasn't changed, even though you unwrapped it. The only weird part is finding this number of that dimension. Because we already have the area of the top and bottom of the can. That's just using the circle formula. But this number, where I'm getting this length here of that rectangle, that can, it's actually just the circumference of the can. It's how round it is. That's your distance for the whole aluminum. Because you cut straight at the top. So if you have the circumference of the circle, you actually have this dimension. Circumference, if you don't know how to find circumference of a circle, it's 2 times pi times r. 2 pi r. That's how you find the circumference. And that'll be this dimension. So really, I only need 2 numbers in that picture. I need the height, and I need the radius. That's really all I need. So I'm going to make up a height numbers. Can somebody give me a number, please?
7.
7 number. 7, let's go inches. Radius.
5.
5. I heard 5. That's quick on the draw. 5 inches. All right. So we got. If I want to find surface area on this problem, I have to find the area of the top of the can, area of the bottom of the can. That's my first step. So area is you take the radius squared, so 5 inches squared. 5 inches squared, and then you take it times pi. So 5 squared is 25, it's 5 times 5, and then you multiply it by pi, and the label on this is square inches, right? Because that's 5 squared is 5 times 5, and then the inches are squared, and the pi just gets stacked on. If you actually want to multiply that, pi is 3.14, you can take that times 25, it gets something around 75-ish for inches. So that's the area of the top of the can. So I'm going to add that to itself. So here's the top of the can. I'm going to add that to the bottom of the can, which is basically the same dimension. So there's the area of the top and bottom of that Campbell soup can. And now I need to add the whole aluminum in the middle. Well, the aluminum in the middle was 7 inches, and the circumference of the circle going all the way around the can is 2 times your 5 times pi, and that would be the distance around. So what's 2 times 5? 10. So that's 10 pi inches. And pi is 3.14. So if you take 10 to 3.14, you get, what, 31.4? Something like that. So that's roughly the number. So the area of this is 7 times 10. That's 70 pi square inches. That's the actual area. Now, if you do a pi is 3.4, you take that times 70, you get like something like 210. Like that. So and now we can add these all together. And notice the surface area is always in square inches. So you'd add those 3 numbers up, and that is 50 plus 70, which is 120 pi inches. You actually add those all up. That's the idea. That's how you do it. So that's the surface area. Again, top of the can, which is pi r squared, bottom of the can, pi r squared, and then you use the circumference for the length of that rectangle, the aluminum. Now, they have this crazy looking formula over here. It's the same thing. It's just what I just showed you. You're adding the top and bottom of the can, that's pi r squared, there's 2 of them. And then you're finding the circumference of the circle times how tall it is. So that's just how they're doing it. But I don't think of it that way. I don't think of just memorizing a formula. I think about, like, what are the pieces and how do I find them? Okay, now volume. Volume is pretty easy. For a can, it's just like the deck of cards. You find the area of the top of the can, which is the 25 pi inches squared. That's the area of the top of the can, pi inches squared. And you take that times how tall the can is. That's all you do to find it volume of a can. So it's area of the bottom times how tall that thing is. That's how I did it for the deck of cards. Find the area of the first card, take it times how tall the cards are. So when I do this, 25 times 7, what is that? That's a 5, carry a 3, it's 175 pi inches, and that's cube. 175 pi inches. That's the volume. why you'd ever want to know volume? It's literally how much liquid fits in that object. It's also the weight of the object in water. So it can tell you a lot in metric systems. So that's how you find it for a cylinder. Now, for these other weird shapes, a lot of people don't understand this, like when you do a pyramid. They don't understand like where do these weird formulas come from. Now, to find surface area, you just find the area of the triangles, all four of them, the volume, or the area of the base, which is the rectangle you just had before. I don't like this stupid formula. So, but to find the volume, you have to have this one memorized. This is a formula you have to have memorized for a pyramid. If you're going to do a maths test, ACT, SAT, if you're going to take one of those college entry exams. This is just a formula. I can't show you anything about it. I mean, this is just, you just have to have it memorized. It's the area of the base, hence how tall the pyramid is, and you always multiply by a third. You're probably wondering, why a third? That's stupid. Like, I don't understand where the third's coming from. Well, here's my visual aid. If it wasn't a pyramid, it would be a triangular prism, which is this. It's got a triangle on the top, triangle on the bottom, and it's straight up and down, right? Well, why this formula has a third is because if you look at this triangular prism, there's 3 pyramids in there. There's 3. There's a pink one, a green one, and a yellow one. They're thirds. If you take pyramids and you put them together where they have roughly the same dimension, 3 of them make a perfect triangular prism. And how you find the area of a prism is you take the area of the bottom, the base, times how tall it is. Well, you're doing a pyramid, so you need a third of that. You only need one of these colors, not all 3 of them. That's why they have 1/3. That's how it works for a cone. You can actually put 3 cones together to actually make a full cylinder. Sphere is a completely different formula. To find a sphere, you just have to memorize that one. In fact, you actually have to memorize the surface area formula for that too, because I have no idea how that works. All right. Questions, comments, concerns? Okay. Bam. You need to leave. I will also be leaving here in a minute. Everyone else, you have a free work time. Okay.
Wait. So remember
All done. Thank you. Go.
what's his name?
And I like to keep that completely anonymous. So only the office person. The reason why I like to be surprised. So I'm not like accidentally talking to them all. Got it split. So I'm a terrible one. So.
What is it? Yes, right here. Thank you. Really cute, like Maddie, come here.
I'll go bring you the bag. Let me try
Just like talking.
There.
It's
hot. It's really hot.
He's not easily embarrassed. Probably homework to work on.
Yeah.
So you're left. So good luck. Alright, hey, go sit. Now watch your game.
Yeah, take a seat somewhere, guys. Oh yeah. Let's find a seat for now. No one around. Hey Fred, you want to find a seat, please? You can talk and hang out. Just find a seat. Mr. Chenoweth's class.
This is actually really challenging. Oh, wait, I see it. I have clothes under it. It's all good. I don't have any. Actually,
I like to control that. It's like red light.
So this is your second. Alice is destroying it.
Do you want to destroy my turtle?
There's other people that are in that class.
I don't know. It's right, but I don't
Oh,
like
yeah.
it.
Sit over here.
What's going on, bro? What's going on, Bonnie?
That's what you did yourself.
What's that? I did my socks.
Oh, but look at my dad's.
See? Come on, water in my head.
Oh my gosh.
There you go.
Oh, my socks.
Buck is beautiful. Leave him alone.
So like most of this clothes is my brother's, so
Why?
I call it's a new strap. What? It says somewhere in the rules it says so true.
Hey, Lon.
What?
Pretty good.
Mr. Kimshaw, you hate me,
I said no.
No.
Hey, Ryder Cup tomorrow. Pay attention, folks.
For what?
You want to hear a joke?
Only the greatest sporting event of the year starts tomorrow.
What is it?
The Ryder Cup.
Well, do you want to hear a joke? Golf.
What's up?
What's the dinosaur when it gets out of the pool? Turtle. You know what?
I've actually heard this before.
What?
What is it?
I can't think of it.
What's the dinosaur when it gets out of the pool? What?
Yeah, I've heard that.
Oh my god, what?
Wait, that's it?
That's it.
Joke? Okay. Why is it a dinosaur? It's the answer. No.
Yeah, could be a banana.
There you go.
Rachel won. What? You don't want it?
I'm Rachel 1, you're Rachel 2.
By 7 days.
By 7 days.
They don't want to show the background. The background's just all black.
You didn't open anything?
I'll show you like I'm getting my bed. I'm not showing. Don't touch it, you guys touch it. No, everyone needs to touch it. Just play like, come on, look at this.
No, I'm not talking about that.
Oh, this? Here you
No, it's like, I'm your...
Looks like a recliner. Looks like a nice one.
How's your day, Mr. Kimshaw?
Just so bad.
Pretty good.
Are you expecting me to say a root
What?
Are you expecting me to say a root
I lift my leg.
I was waiting for it.
I wasn't going to say something. I'm trying to be very hostile.
Yeah,
I'm trying to be hostile.
I don't know.